Chapter 5, we looked at exponential functions and logs. We started with this equation for an exponential y equals a times b to the x, where a is the starting value at time 0. And we looked at how can you tell if it's growth or decay. So when the absolute value of b is greater than 1, that was when it was increasing, so that's growth. And decay would be when the absolute value of b is less than 1. That would be decay. So for example, if we had y equals 3 times 2 to the x, that would mean we're starting with 3 of something. And the 2 would mean it's growing. It's doubling for every, if it's years, seconds, whatever x is doubling every time. So we spent some time looking at those equations. We looked at rules of exponents and how you would simplify. So if we do a few of these to review. The first one, take a look at the 4 and the 6. What can you reduce, or what can you divide each of those by? You can divide them each by 2 and reduce that to 2/3. Then look at your x's. So you have 5 on top and 6 on bottom. So when you reduce, there would be 1 left on the bottom. So we would have an x on the bottom. And then look at your y values. Again, we have 11 on the top and 7 on the bottom. So when you cancel, there would be 4 left, but they would be on the top because there's more on the top. So there's the answer for that one. The next one, power to a power. We're going to distribute the 4. So first we have 2 to the 4th. We have x to the 4th. And if we have an exponent, you're going to distribute and multiply. So 3 times 4 would be 12. We can simplify 2 to the 4th even further. That would be 64, x to the 4th, y to the 12th. And then the last one, oh, actually it's not 64, I'm sorry, 16. Let's change that. That would be 16, x to the 4th, y to the 12th. And then the last one we looked at, if there's a negative exponent, if you flip the base with this exponent, becomes positive. So b squared I can flip to the top, it becomes positive, and a to the 5th I can flip to the bottom, and that would become positive. Near the end of the chapter we looked at logarithms. Erase this. Know when and how to use them to solve an exponential. And so you're going to use a logarithm whenever the variable that you want is in the exponent. So for example, if we had y, or let's have a number here, let's say we had 5 equals 3 times 2 to the x. When x is in the exponent, you can use a log to solve. We also looked at using guess and check. So when the variable is in the exponent, the log is the inverse and it undoes the exponent. So when the variable is in the exponent, you can use a log to solve. So let's do an example. Let's say you buy a car for $4,000 and the value of the car depreciates by 20% per year. When will the car be worth half of its value? Okay, so let's set up the equation. Half the value would be 2,000, and that would equal 4,000. And then we have 1, and it's going down by 20% a year, so change 20% to a decimal point 0.2 or 0.20, and then we'll solve for time here. In order to use a log to solve, we have to get the base and the exponent by itself. So let's simplify this a little bit further. So 1 minus 0.2 is 0.8. If your car is losing 20% of its value every year, it's still worth 80% of the year before. Okay, so again, in order to use a log, we want to get this base and the exponent by itself. So let's get rid of that 4,000 by dividing. Okay, so when we do that, we have 0.5 equals 0.8 to the t. You can use guess and check here, but if you use a log, the base of the log is the 0.8. So we're going to say log of 0.8, and then you loop it around of 0.5 equals t. And now you can type that in your calculator. So when you do that, it will give you the exact time, but then I'll round it, so I guess I'll make it approximate. So we solve time is about 3.106 years for that car to be worth half of its value. We looked at the credit card problem and simple compound interest and also continuously compounded interest. So let's review those equations and when to use them. So for simple interest, if something's annually or once a year, we have the amount equals the P, the starting value, 1 plus or minus your rate. I use plus, but it could be plus or minus your rate. And T is number of years. If it's compound, this is when something is, the interest is calculated more than once a year. The amount, oops, don't know what I did there. Okay, there we go. So the amount here, let's change colors. Starting value again, 1 plus or minus. But now you take your rate and you divide by how many times per year that's compounded, and then you have to multiply it by how many times per year it's compounded as well. And then APERD is when it's compounded continuously. So when you see that word continuously, it's going to be PE, and E is that not imaginary. E is that number that we've the 2.7818 number that we used to calculate when finding a limit. We saw that in the credit card problem. And then R is the rate and T is the time. So those are the main equations that we use for that chapter. And there's several practice problems for you to try, and you can check your answer with the answer key online.